All right, on today's episode of Python Papi, we're back inside our TensorFlow course and we're still doing our malaria diagnosis data prep module. Let's have a look at what we went over today. Now, yesterday, if you recall, we were in the process of shuffling our data around and going over those steps. Now, today, we're actually going to pick up exactly what I was talking about last night about the holdout cross validation, but it's not called that here, but that's exactly what we're going to be doing. So let's go over it right now. In order for us to create the train validation and test set, we are going to make use of the take method and the skip method. So let's look at this example. We have this little data set, we'll create it, and we want to print out the data set after skipping 7 values. This is how we will code the entire process. Let me start compiling now so I can actually show you the results. It's not that big of a file, so it shouldn't take that long. So we have our data set equals tf dot dataset dot range 10. That's going to give us a list of a range of 10 elements. Then we have dataset equals dataset dot skip 7. That's going to actually skip the first 7 elements in that list, and then we're going to print it out. So I did it already, and this is the output we got. We got 7, 8, 9. So out of a list of 10 elements, we will return the last 3 because we skipped the first 7. So we skipped 0 through 6, and we return 7, 8, and 9. Now notice that with the skip formula, we are skipping the first 7 elements in the values list with a range of 10. That's why we return the last 3 values, like I said. All right, next we're going to use the data set, or the same exact formula with the data set equals tf.dataset for the range of 10, but this time we're going to use the data set equals dataset.take 6. Now with this, we're going to get the first 6 elements of the range of 10. So out of the elements, or out of all 10 elements of the range of 10, we're going to return the first 6. As you can see here, we have the output of a 0, 1, 2, 3, 4, 5. Our first 6 elements, you can see here, everything did compile already. So it's 7, 8, and if you follow my cursor, we have the 7, 8, 9 from the skip, and we skipped the first 7 and got the last 3. And then the next one, we got the first 6 elements out of our range of 10, and we left out the last 4 because we only wanted the first 6. So with that being said, let's move down to what else we worked on today. And we actually created some training ratios, some validation ratios, and some test ratios here. So we have 0.8, 0.1, and 0.1. That's going to equal out to 1, or that's going to equal out to 1. It always has to equal out to 1. That's a whole different module right there, but just follow along with me. And then we have our data set equals tf.dataset. That data set is still using our range of 10. And then we're going to print that out to actually show us that we had our elements here, 0 through 9, to show us our range. And then we printed out the length of our data set to make sure everything was matching up, and that returned 10. Now notice that we will return the list with each element in our range of 10, like I said, and also notice that we will return the length of the list, which is 10. Now that's set. To obtain a trained data set, all we need to do is simply take the first 80% of our data set using the take function. So let's go down and see what that looks like here. This is how we would define, or this is how we perform this. First, we would define a data set. Next, we will multiply the 0.8 or 80% by our data set size or length. And lastly, we will use the print to actually print it out. Now, this is exactly the method we went over. We had the data set size equals the length data set. Then we had the trained data set equals data set dot takes. You have to use integers when we're using integers. 0.8 times data set. And then we return that, and this is what we got back. We got back the first 80% of our length of 10, or our range of 10. So 0 through 8 will be the first 80% of the elements in our range of 10. Now, actually comment all of that out. It's not in our compilation because I didn't want it to conflict with the later processes that we did, because we use the same stuff. So yeah, that's just with that one there. I had to explain to you manually. So with that, we had the first 80% of our range of 10 got us back the first 8 elements inside of our range of 10, which is 80% out of the 10. Next, we will change the train ratio, validation ratio, and test ratio to see more examples. And that's what we did it down here. We actually left this one the same, but we didn't comment this one out so you can see it in the computations below. And we're going to go over that one now. So we have a test ratio of a 0.6, validation ratio of 0.2, and a test ratio of 0.2. Then we have the data set equals tf.dataset, showing that we want our range to be 10. Then we printed that out to actually show it. Then we have the data length size to show the length of that. And then we are going to put the train data set equals dataset.take. And then we're going to take the integer training ratio. It's going to be 0.6 times the data size. And then we printed that out. So let me get and show you everything that we have down here. It's down here in the compilation. Hold on. Okay, so you see here we have our list, our range of 10. And then we have here our 1 or 0, 1, 2, 3, 4, 5. That's going to represent our 0.6 or our 60%. So With the 0.6, which is specified here with our train ratio times data set, we only wanted 60% of the elements out of our range of 10, which got us back the first 6 elements out of our range of 10. So that's why you see here we only have the 0, 1, 2, 3, 4, 5, because that's exactly 60% of 10. 6 elements is 60% out of 10 elements, and that's what's returned. And then we are left with 40% return or not use data. As you can see here, we have specified validation is a 0.2 and testing is 0.2. Add those two up and we have 40% or 0.4. So that's why we have 40% left over. So notice that we will return the first 60% of the elements in our list of range of 10. Also notice that we are left with the other 40% of elements remaining. And that's all that is right there. So, like I said, we did reach a point of convergence where our artificial intelligence course and our TensorFlow course are converging perfectly, and everything is starting to click a lot more, make a lot more sense now. I was using the tools already, and I was getting a handle on using the tools, but now I know exactly what the tools are doing and exactly why they are doing what they are doing. So yeah, things are moving smoothly, and I actually spent about 2 hours straight, 2.5 hours straight, just having trouble-free coding this morning. It was a very peaceful experience, say the least. But yeah, like I said, we're gonna keep moving forward, and I'm gonna keep you guys posted every step of the way. But for now, this is the Python Papi. You guys stay Gucci.